Let's look at trying to find the exact value of the sine of 45 degrees times the cosine of 45 degrees, again without using a calculator. So we're going to use the unit circle to help us with this. 45 degrees, those are in the first quadrant. So if we recall back to the unit circle, in the first quadrant, the 45 degree angle, if we look at this, right, if we have our 45 degree angle in the first quadrant, the point where the point intersects our circle, it has an ordered pair of the square root of 2 over 2, comma, the square root of 2 over 2. So if you recall that from the unit circle, right, where the angle intersects our circle, those are the ordered pairs. Now, if you remember, the sine is just the y coordinate where our circle intersects the angle, and the cosine is just the x coordinate. The cosine is the x coordinate. So we can just take our y coordinates and our x coordinates and multiply them. So this is the sine and this is the cosine. So we can just take those products. So we have the square root of 2 over 2 times the square root of 2 over 2, right? Because this is the sine of 45 degrees and this is the value of the cosine of 45 degrees. So when we take this product, the square root of 2 times the square root of 2, that's the square root of 4. And then 2 times 2 is 4. So we end up with the square root of 4 over 4, which turns out to be 2 over 4, or 1/2. So this entire product simplifies to be 1/2. And we can evaluate that without using a calculator by knowing these values on the unit circle. So let's take a look at another example. In this example, we want to find the exact value of 2 times the sine of pi over 3 minus 3 times the tangent of pi over 6. So again, if we consider the unit circle, both of these angles are in the first quadrant. So if we consider the unit circle in the first quadrant, pi over 3, that's like a 60-degree angle, so it's going to be something like this. And then pi over 6, that's going to be a 30-degree angle, so it's going to be something like this. And then the points where our circle intersects these angles, at pi over 3, the ordered pairs are 1/2, comma, rad 3 over 2. And then at pi over 6, it's rad 3 over 2, comma, 1/2. So now, when we're thinking about the sine, remember the sine is just the y coordinate. So at pi over 3, the y coordinate is rad 3 over 2. So this is 2 times the square root of 3 over 2 minus 3 times the tangent. The tangent of pi over 6, that's the y divided by x. So it's the y coordinate divided by the x coordinate at pi over 6. So it's going to be 1/2 divided by rad 3 over 2. So 1/2 divided by the square root of 3 over 2. And then we will simplify this to give us our final answer. So we can take this product, and we know that 2 times divided by 2, that's going to cancel. So we're left with the square root of 3 here. And then it's minus 3 times. Now, if you recall, when you divide a fraction by a fraction, we keep the numerator as is, so it stays 1/2. And then we multiply by the reciprocal of the denominator. So it's going to be 2 over rad 3. Now again, the 2's will cancel, and we're left with the square root of 3 minus 3 times 1 over rad 3. So we have 1 over rad 3 here. And we can take this product here, and we get square root of 3 minus 3 over rad 3. And then rationalize. And to rationalize, we're going to multiply the numerator and denominator by the square root of 3 for the second term. And we get, so 3 rad 3 over 3 So the square root of 3 minus 3 rad 3 over 3. Lots of 3's. These can simplify, and we end up with the square root of 3 minus the square root of 3, which actually just turns out to be 0. So all of this whole thing, simplifies to just be 0.